Hello friends, this is the second video in the CSES Sorting and Searching video series. In this video, we will be solving the problem number 2, which is apartments. So the problem statement is, there are n applicants and I am free apartments. Your task is to distribute the apartments so that as many applicants as possible will get an apartment. Each applicant has a desired apartment size and they will accept any apartment whose size is close enough to the desired size. The input is, the first input line has three integers n, m and k, the number of applicants, the number of apartments and the maximum allowed difference. The next line contains n integers a1, a2, an, the desired apartment size of each applicant. If the desired size of an applicant is x, they will accept any apartment whose size is between x minus k and x plus k. The last line contains m integers b1, b2, bm, the size of each apartment. In output, we have to print single integer, the number of applicants who can get an apartment successfully. Constraints are n, m is greater than or equals to 1 but lesser than or equals to 2 into 10 raised to power 5. Then k is greater than or equals to 0 but lesser than or equals to 10 raised to power 9. ai, bi is greater than or equals to 1 but lesser than or equals to 10 raised to power 9. Then we are given a sample case. We will discuss that as well. First, let's see what the problem is. So the problem is very simple. We are given n customers, each with a desired apartment size, and we are given m apartments. Each apartment has a fixed size. We have to service as much customers as possible, but the trick is that we are given a k, where every customer who is asking for an apartment of size x, he will accept any apartment only if that apartment size is in range of x minus k to x plus k, where x is the desired size of that customer and k is a given fixed value. So first let's see the answer for sample case, that how we are getting 2 for sample case. So if we will see, look at the sample case. So we are given 4 customers, 3 apartments, and the value for k is 5. So how we are getting 2 is, we can provide customer with, one customer is asking for size 60, so we can provide him an apartment of size 60 because he is asking for size 60 and k is 5, so he will accept anything between 55 to 60. So sorry, my bad. He will accept anything between 55 to 65. So we can allocate this second apartment to the second customer. Then other than that, we can allocate third apartment to the fourth customer, because fourth customer is asking for size 80. So we can allocate him anything between 80 minus 5, that is 75, to 85. So this way the answer would be 2. Now let's see what would be the approach for solving this problem. So what we can do is, if we arrange our customers and apartments in ascending order, here we have already stored them in ascending order. So what we would be doing is, if we start from the first customer, can we allocate first apartment to the first customer? First customer is asking for size 45. He is asking for 45. That means he will accept anything between 40. This is the lower range he is accepting, and this is the highest he is accepting. He will accept anything between 40 to 50. So, but the apartment size is 30. Can we satisfy this customer? No. The apartment size is smaller compared to his desired size. So can we allocate this apartment to some other customer? No, because because both the arrays desired size and apartment size are sorted in ascending order. So if this customer is saying that this apartment is smaller for him, the customers who would be next to this customer would also be saying the same, because their desired sizes are even larger than this one. So this apartment is of no use for us. We will move forward and remove this apartment. Now can we allocate second apartment to the first customer? First customer is asking for size in range 40 to 50, but the apartment size is 60. This apartment is larger for this customer, so we cannot allocate this apartment number 2 to customer number 1. Can we allocate some other apartment to this customer? No, because if this apartment is larger for this customer's requirement, then the apartments which would be next to this apartment would be even larger. So this customer cannot be satisfied anyway, as his apartment size is smaller compared to the current, his desired size is smaller compared to the current apartment size. So we will now try to allocate the same apartment number 2 to the customer number 2. Can we allocate apartment number 2 to customer number 2? Yes, because he is asking for size 60. That means he is asking for size in range 55 to 65, and the apartment size is 60. So this apartment, second apartment, could be allocated successfully to the second customer, and our answer will become 1. Answer is equals to 1. Now after allocating second apartment to the second customer, since this customer has been satisfied, we will move to the third customer, and since second apartment has been sold, we will move to the third apartment. Can we allocate third apartment to the third customer? No, because he is also asking for 55 to 65. Since he is asking for size 60 and the value for k is 5, so his range is 55 to 65. We cannot allocate him an apartment of size 75. Then, since this customer is asking for a smaller apartment, we cannot satisfy him anyway. We will move to the fourth customer. Fourth customer is asking for size 80, so his range will be 75 to 85. So we can allocate this particular apartment to him. So our answer will become 2 instead. Now how we will write the code for this problem? Let's see. Let's write the solution. Integer n, then m, and then k. We will take input for n, m, and k. Then we will create vector of int type, desired size of size n. Then we will create another vector of size m, which is apartment sizes. Then we will be taking inputs for integer I is equals to 0, I is lesser than n, I plus plus, c input, desired size of ith customer. Then we will be writing our second loop for int I is equals to 0, I is lesser than m, I plus plus. These are apartment sizes. Then after taking desired sizes and apartment sizes, what we will do is we will sort them. Sort desired size dot begin and desired size dot end. Then we will sort apartment sizes as well. We have sorted desired sizes and apartment sizes. Now what we will do is we will take a variable int ans equals to 0, I equals to 0, j is equals to 0. Our answer variable will be holding the current answer. I will be holding the current customer and J will be holding the current apartment. While I is lesser than n and while I is lesser than n or not or n. Why we will be taking n? Because and J is lesser than m, because we will be running this loop only till then while we have a valid customer and valid apartment. If all our customers are satisfied, even if we are having apartment, there's no sense in moving forward. And if all our apartments already have been allocated, even if we are having customers, there's no sense in moving forward. So there should be a valid customer and apartment both, only then we will be proceeding with the loop. Then in loop we will check, can we allocate this apartment to the customer? How we will check? We will check absolute value of desired size of ith customer minus apartment size of jth apartment. We will check the absolute value for this. If this absolute value is lesser than or equals to k, then it's possible to allocate this apartment, this jth apartment to the ith customer. So in that case, answer will be incremented, then I will be incremented, and then j will be incremented. After that, else if customer is not, if this particular customer cannot be satisfied with this apartment, then there could be two scenarios. Either the desired size of ith customer is lesser than apartment size of jth apartment. In that case, we will move to the next customer. Else we will be moving to the next apartment, because in this last else means कि desired size is greater than apartment size. Since apartment is too smaller, so we will move to the next apartment. And at last, we will output our answer. Let's check it for the sample case. Let's try to submit it. Our problem has been submitted successfully. Thank you, everyone. We will be continuing with the next problem in next video.